These findings challenge every cornerstone of cosmic history. If enormous galaxies can appear so soon, are the Big Bang and our most trusted models of creation suddenly on shaky ground? What else could be wrong about our universe if even its timeline is up for debate? Imagine if a historian discovered medieval tassels built during the Stone Age. That is how shocking these galactic revelations are to astronomers. What if the very fabric of your reality was just ripped apart by new evidence? Imagine waking up one morning to discover that everything you took for granted about the universe, how it began, how it grew, even why it looks the way it does, was suddenly in question. That is not just a hypothetical scenario. It is happening right now, in our lifetime, catalyzed by the most powerful space telescope humanity has ever built, the James Webb Space Telescope. With these observations, the cracks in our understanding are starting to show. Mainstream cosmology claimed galaxies should take eons to form, slowly assembling their stars from clouds of primordial gas. Instead, Webb has revealed gigantic, fully mature galaxies blazing away only a few 100 million years after the supposed birth of time itself. It is as if you wandered into a desert expecting new sprouts, but instead found towering forests, fully grown and thriving. To fully appreciate just how earth-shaking this is, let us recall that previous observations, like those from the Hubble Space Telescope, hinted at early structure. But never at this scale, and never with such certainty. For generations stretching back to the earliest astronomers, scientists have relied on theories like the Big Bang to explain how everything began, how galaxies emerged, and why the universe looks the way it does. These models painted a universe that started tiny and chaotic, gradually building up structure over billions of years. Just as Isaac Newton's laws once gave us comfort about the motion of the planets, and Albert Einstein's relativity changed the way we see gravity, the Big Bang model has been a bedrock, our cosmic origin story. But now something extraordinary has shattered that comfort. The James Webb Space Telescope, or JWST, has spotted ancient colossal galaxies, far older and more massive than any theory predicted. Let us look closer at how the James Webb Space Telescope's discoveries have forced experts to rethink the story of the universe and what might come next. To do that, we have to journey back, not just in space, but in time, to when our cosmic detective work first began. The consequences are staggering. If this cosmic puzzle piece holds true, scientists may have to rewrite their textbooks, question decades of research, and re-examine the scientific consensus that shapes our view of existence. Billion-dollar missions, lifetimes of work, and our most basic beliefs about space and time are now at risk. The ripple effects would be felt across every branch of science, astrophysics, chemistry, even philosophy and theology. Humanity's 12th, 2022, humanity's vision of the universe changes forever. The James Webb Space Telescope opens its golden eye, and in a single moment, the cosmos becomes stranger, more beautiful, and more unsettling than we ever imagined. Decades of planning, billions of dollars, and the hopes of thousands of scientists all converge on this single point in history. How did the universe begin, and what did scientists expect to see? To answer that, we need to go back to the foundational models that shaped modern cosmology. The 20th century was a golden age for theoretical physics. Edwin Hubble discovered the universe is expanding. Georges Lemaitre and Alexander Friedman developed the mathematics predicting a universe that had a beginning. Later, the discovery of the cosmic microwave background by Arno Penzias and Robert Wilson in 1965, an echo of the primordial fireball, seemed to confirm the Big Bang theory. For decades, scientists believed they had the broad strokes of the universe's story. From its very first images, Webb delivers a shock. Thousands upon thousands of galaxies, each a metropolis of stars, come into focus with breathtaking clarity. Where Hubble once teased the universe's secrets, Webb now reveals them in dazzling, intricate detail. Stellar nurseries, tangled rivers of gas, ancient galaxies stretching back to the beginning of time. Consider the Hubble Deep Field from 1995. That single grainy image, captured over 10 days, revealed about 3,000 faint galaxies in a patch of sky the size of a grain of sand held at arm's length. Webb's first deep field, by contrast, revealed thousands of galaxies in a fraction of that time, each with details Hubble could never see. This is not mere improvement. Webb's clarity is a revolution. Compared to Hubble's deep field, which hinted at the distant cosmos, Webb's infrared vision slices through dust and shadow, uncovering drama and structure Hubble could never reach. We see spiral arms twisting like cosmic whirlpools, enormous clouds of gas sculpted by infant stars, and the ghostly arcs of light bent by gravity's invisible hand. Imagine looking at an old black and white photograph and then suddenly seeing the same scene in ultra-high-definition color. That is the leap in clarity Webb has given us. This is more than a gallery of wonders. It is a turning point. To ignore these discoveries is to miss the most important revelations of our time. The James Webb Space Telescope is not simply updating our cosmic address book. It is challenging the bedrock of what we thought we knew. If you do not pay attention, you risk being left behind as everything we thought was certain begins to crumble. Yet Webb's breakthroughs are not limited to distant galaxies. When it peers into glowing nebulae, the birthplaces of stars, the telescope peels back layers of dust, revealing hidden architecture and binary stars previously unseen. In the Southern Ring Nebula, Webb exposes not one but two stars at its core, overturning old assumptions about how these shimmering clouds are shaped. In the Carina Nebula, Webb captures towers of gas and newborn stars erupting into life, their fierce winds carving vast chasms in the interstellar night. Before Webb, astronomers could only speculate about the chaotic nurseries where stars are born. Now they can watch the process in near real-time detail. Webb's reach extends to distant worlds. By observing the slight dimming as a planet crosses its star, Webb collects clues about alien atmospheres. In its earliest triumphs, it detects hints of water vapor in the skies of a planet light years away, fueling hopes that habitable worlds may exist beyond our solar system. Not only does this bring us closer to answering the age-old question, are we alone? It also demonstrates the immense power of Webb's instruments, which can distinguish tiny differences in starlight from worlds dozens or even hundreds of light years away. Through gravitational lensing, Webb watches light from hidden galaxies bend and stretch around colossal clusters, creating mirrored echoes and multiplying images. This phenomenon, first predicted by Einstein over a century ago, is now routine in Webb's observations. For the first time, astronomers can observe supermassive black holes feasting at the hearts of galaxies whose light began its journey before our sun was born. Colliding galaxies, once only theoretical, now play out before us in high definition, exposing a universe that is wild, violent, and unpredictable. Galaxies merging, devouring, and transforming each other over billions of years. Webb's images of Stephan's quintet, a group of 5 galaxies, show tidal tails, shockwaves, and even a supermassive black hole emitting energy equivalent to 40 billion suns. These are not mere scientific abstractions. They are snapshots of cosmic drama unfolding on a scale that dwarfs our imagination. But the real shock comes next. Astronomers find galaxies that, by every established rule, should not exist. Not this early, not this massive, not this bright. And with that, the universe throws down a gauntlet. Consider the analogy of discovering a fully formed metropolis, complete with skyscrapers and highways, in what should have been a prehistoric wilderness. With these impossible galaxies, the first cracks appear in our most trusted theories. Suddenly, the foundations of modern cosmology, galaxy formation, dark matter, even the Big Bang itself, stand exposed, vulnerable to doubt. It is reminiscent of the moment when Copernicus challenged the geocentric model, or when quantum mechanics upended classical physics. Each time, established wisdom was forced to yield to new evidence. How could gigantic, fully formed galaxies have emerged when the universe was still in its infancy? This is the cosmic riddle the James Webb Space Telescope has hurled at astronomers. a riddle with the power to shatter everything we thought we knew about how the cosmos began. The mystery deepens when you consider that these galaxies are not alone. Webb has spotted several such examples, each more baffling than the last. Webb peered deeper than any instrument before. It discovered 6 so-called universe-breaker galaxies. These ancient giants are not just outliers. They are impossibly bright, massive, and mature for their time, existing when the universe was only a few 100 million years old. According to decades of cosmological theory, such complexity and size should have taken billions of years to achieve. It is as if you found a fully grown redwood tree in the middle of a sapling forest. For years, scientists pictured the first galaxies as chaotic and primitive, fragile collections of stars slowly organizing over eons. But Webb has revealed colossal structures, brimming with stars and heavy elements, more like bustling cosmic metropolises than newborn hamlets. These findings directly contradict the idea that galaxies must begin as small, scattered systems and gradually grow up. For example, the galaxy known as GN-11 appears to have formed just a few 100 million years after the Big Bang, yet contains a mass of stars comparable to the Milky Way. This is not supposed to be possible under current models. How did the universe manage such a dramatic shortcut? Some researchers think early star formation was wildly more efficient, perhaps driven by unknown cosmic ingredients or processes. Maybe vast reservoirs of matter, or unusually potent dark matter, supercharged galactic construction. There are even suggestions that the rules of star formation itself might have been different in the early universe, with stars forming faster and more prolifically. Others dare to wonder if the very laws that govern cosmic growth need rewriting, if our most trusted physics is missing something fundamental. Could there be unknown forces or particles at play? Then there are the supermassive black holes, monsters with masses millions or even billions of times greater than our sun, already lurking in these ancient galaxies. Standard theory says black holes grow slowly, through countless mergers and slow feeding. Yet these cosmic giants seem to have appeared almost overnight, sidestepping the steps the universe is supposed to take. It is as if whole chapters of the universe's story have been torn out and replaced with something entirely unexpected. For instance, in the galaxy JWST Z1306, a supermassive black hole seems to exist only 375 million years after the Big Bang. According to current growth rates, such a black hole should not exist until billions of years later. The mysteries deepen. Webb has spotted galaxies that seem to defy predictions about dark matter, some with far too little, others with an apparent excess. The expected types and numbers of galaxies at different early times simply do not match what Webb's data shows. Each new observation chips away at the foundations of our cosmological model, revealing cracks where we once saw solid ground. For example, one study found that the abundance of bright, massive galaxies at redshifts above 10, meaning less than 500 million years after the Big Bang, was at least an order of magnitude higher than predicted. This is not just a minor adjustment, it is a crisis for the standard model. The consequences could not be more profound. If our leading theories of galaxy formation, black hole growth, and even the age of the universe are wrong, we may be on the threshold of a scientific revolution. Every textbook, every Nobel Prize, every cherished assumption about our universe is suddenly in play. This is reminiscent of the early 20th century, when the discovery of quantum mechanics rendered classical physics incomplete. It is the kind of moment that only comes along once in a generation. With every image, astronomers find themselves forced to question everything: dark matter, the timeline of cosmic history, even the origins of space and time itself. If the universe built galaxies and black holes this quickly, what else might we be missing? The next wave of discoveries could challenge the very fabric of our reality. Imagine what will happen when next-generation telescopes, like the Nancy Grace Roman Space Telescope or the European Extremely Large Telescope, begin their work. The surprises may only multiply. Could our universe have emerged in a completely different way? or possibly never had a true beginning at all. This is not just idle speculation. Throughout history, paradigm shifts have occurred when new evidence forces us to abandon cherished models. When the heliocentric model replaced the geocentric, when plate tectonics reshaped geology, when evolution challenged static views of life. Each time it took courage to accept the new reality. Could we be living through such a moment right now? With every new image from the James Webb Space Telescope, astronomers are forced to consider bolder possibilities. Some now imagine a cosmos without a single center, a reality where creation erupts spontaneously everywhere, or even a multiverse shaped by titanic collisions between entire universes. Not long ago, such ideas would have belonged only to science fiction. Today, they are fueling heated debates among leading researchers. For example, the cyclic universe theory, proposed by Paul Steinhardt and others, suggests the cosmos undergoes endless cycles of expansion and contraction, never truly beginning or ending. Subtle clues keep surfacing in the cosmic microwave background, that faint afterglow left from the universe's earliest moments. Mysterious patterns and unexpected cold spots defy the predictions of standard models. Some physicists now wonder, could these be the ancient scars, echoes of violent encounters with other universes, etched forever into the fabric of space and time? The so-called CMB cold spot is one such anomaly. Its origin is still debated. Some suggest it could be evidence of a collision with another universe. Another enigma persists, the cosmic imbalance between matter and antimatter. By all rights, the Big Bang should have created equal amounts of both, yet we find ourselves in a universe made almost entirely of matter. This stubborn puzzle casts doubt on the idea of a singular, pristine beginning and urges scientists to explore more radical origins. For decades, physicists have searched for even the slightest evidence of antimatter galaxies or stars, always coming up empty-handed. If these revolutionary ideas prove true, the familiar story of the Big Bang, the comforting notion that everything sprang from a single blinding instant, may be swept away. In its place, we may confront a universe whose birth is infinitely stranger, tangled, and perhaps forever beyond full understanding. We might have to accept that our universe is just one bubble in a vast cosmic foam, or that time itself is cyclical, with no true beginning or end. As revolutionary as these ideas sound, they raise urgent questions about how we pursue knowledge. Are we prepared to rethink everything we thought we knew about the universe? Can we embrace the possibility that our deepest intuitions might be wrong? Yet the pursuit of these new truths comes with serious risks. To follow the evidence, scientists might have to let go of cherished models and face a reality that is more unpredictable, chaotic, and daunting than ever imagined. The very foundations of scientific research, education, and funding could be upended. Imagine the impact on school curriculums, on research grants, on the direction of entire scientific careers. What does this upheaval mean for us living in the midst of a cosmic revolution? Could these discoveries offer practical lessons, or will they simply deepen the mystery of existence? It is worth remembering that every great discovery has ripple effects beyond science. The Copernican revolution, for example, reshaped philosophy and religion as well as astronomy. When the universe changes, so does our definition of humanity. Consider this. Every time we peer deeper into the cosmos, we discover truths that shake our understanding of ourselves. The James Webb Space Telescope is not just updating the textbooks, it is upending our sense of identity, purpose, and belonging in the vast cosmic drama. Each unexpected galaxy or ancient star forces us to reconsider what it means to be intelligent life in a universe immeasurably older and more mysterious than we dared imagine. The quest to unravel cosmic origins is not reserved for scientists in distant observatories. It is a journey with consequences for all of us. When we finally confront the true age or complexity of the universe, it transforms our ambitions and our sense of destiny. If the cosmos is stranger or older than we believed, then our own story becomes a single thread in a far larger, still unfolding tapestry. Like the shift from thinking the Earth is the center of the universe to realizing we orbit an ordinary star in a vast galaxy, these new discoveries challenge our place in the cosmos. This scientific revolution does not stay in the lab. The technology behind Webb, the ultra-sensitive detectors, the massive mirrors, the feats of engineering, soon finds its way into our everyday lives. Those tiny sensors in your phone camera, breakthroughs in medical imaging, new materials for construction and computing, all trace their origins to the same drive to see farther and clearer into the night. Each time we push the limits of exploration, we end up reinventing life on Earth. For instance, the charge-coupled device, or CCD technology, developed for astronomical observations, now powers everything from digital cameras to advanced telescopes. Yet the greatest change is in our thinking. Webb's discoveries teach humility. Our most cherished theories may be provisional, sketches of a reality deeper and stranger than we imagined. Real progress, scientific or personal, demands the bravery to question everything, even what seems certain. By challenging assumptions, we open the door to genuine breakthroughs, not just about the cosmos, but about ourselves. Recall how the acceptance of quantum mechanics forced us to abandon the idea of absolute certainty in physics, opening new vistas in both science and philosophy. And here is the most humbling realization. The James Webb Space Telescope is only at the beginning of its mission. We stand at the threshold of a new era where each answer leads to even bigger, wilder questions. The universe is not a riddle to be solved and set aside, but a living mystery that grows richer with every step we take. Consider how, after each major discovery, from the moons of Jupiter to the expansion of the universe, new questions have always followed. The cycle of discovery never ends. To look away from these cosmic shocks is to risk losing our edge, not just as scientists, but as thinkers and explorers. If we stop asking the hardest questions, our progress stalls. But if we embrace the unknown, we stand poised for discoveries that could overturn everything we thought we knew about reality itself. Historical parallels abound. In the early 20th century, the discovery of the electron forced physicists to abandon the idea that atoms were indivisible. Later, when unexpected results emerged from particle accelerators, the standard model of particle physics was born. Now, cosmology faces its own electron moment. Will we discover a new cosmic ingredient or revise our most basic laws? But what exactly are these cosmic shocks? Let us look closer at the evidence that is shaking the foundations of modern cosmology. The James Webb Space Telescope's data is freely shared online, allowing researchers worldwide to analyze and debate its implications. Some teams are focused on refining distance measurements, confirming the ages and masses of these early galaxies. Others are simulating possible universes on supercomputers, testing which assumptions must change to reproduce what Webb sees. Still others are developing new theories, modified dark matter, alternative inflation models, or entirely new physics to explain the observations. The James Webb Space Telescope has done more than simply sharpen our cosmic vision. It has upended the very bedrock of our understanding. Each dazzling image, every new measurement, is a challenge hurled at ideas we once thought were unshakable. The universe is not just stranger than we imagined, it may be stranger than we have ever dared to imagine. If you find this unsettling, you are not alone. Scientists, philosophers, and ordinary people alike are wrestling with the implications. Are you prepared to abandon certainty, to face a universe that defies every expectation? It is worth noting that the process of scientific revolution is never easy. Thomas Kuhn, in his landmark book, The Structure of Scientific Revolutions, showed that paradigm shifts are often resisted at first, even by leading scientists. But over time, evidence wins out. The history of science is the story of overcoming our own biases and limitations in pursuit of deeper truth. For generations, our models gave us comfort. The Big Bang, the hidden hand of dark matter, the tranquil unfolding of galaxies. These stories granted us a sense of order amidst the infinite night. But with Webb's revelations, those foundations are trembling. Galaxies that appear impossibly early, structures too immense for their supposed age, and signals that refuse to fit any familiar pattern, all demand that we rethink our most fundamental beliefs. The future belongs to the curious, those who see broken theories not as defeat, but as an open invitation to discover more. Webb's discoveries have handed us a cosmos that cannot be tamed. The next step is ours to take. What happens when reality refuses to cooperate with our most cherished theories? Science thrives on curiosity and the discipline to be proven wrong. Yet surrendering certainty is a daunting leap. It calls for courage, humility, and a willingness to keep questioning, even when every answer unsettles us. The great physicist Richard Feynman once said, "I would rather have questions that cannot be answered than answers that cannot be questioned." Because, in the end, the universe does not owe us answers, but it rewards those who keep searching. Your worldview is at stake. The narratives we craft about the cosmos shape who we are, guiding our quest for meaning. Will you hold fast to what you know? Or will you venture into a universe that resists all explanation? The choice is not just intellectual, it is existential. Our willingness to adapt, to remain curious in the face of uncertainty, will determine the next chapter in humanity's cosmic story. History has always favored those bold enough to look deeper, to challenge what seems certain. As our cosmic story grows ever stranger, will you keep your eyes wide open, or will you turn away from the unknown? The invitation is clear. Embrace the mystery, question the impossible, and join the ranks of those who have changed the world by daring to look beyond.